Okay, so good day, everybody. Good morning, good afternoon, good evening. We'll start the webinar on the guidance on monitoring salt iodization programs and iodine status. We have quite a few people who have signed on already, and we expect more to come. So, but the next few minutes, we'll start going through some of the introductions. It's great to have such a turnout of participants for this webinar. We have registrations from 52 countries, which is quite amazing what technology can do. And you are researchers, government program managers, you're from the business sector, we have laboratory representation, we have people from the UN and from NGOs. What really connects us is the interest in iodine nutrition. So we're really excited to have this an hour and 15 minutes with you. So what can you expect? In the next hour, we will have a presentation on the UNICEF guidance on monitoring salt iodization programs and iodine status that was issued in 2018. We will have a presentation of about 50 minutes. And after that, there is room for your questions and comments for about 20 or 30 minutes. We will try to monitor the questions that you have. And you can type them in the chat box and that you can see on top of your screen. And there you can post your questions throughout the presentation. I will monitor those and then we'll cover them at the end. I'm also asking to please mute yourself. We will record the entire webinar and then we will share the recording later together with the presentation and any other materials by email, and it will be posted also on our website of IGN, www.ign.org. So this webinar is organized jointly by UNICEF and the Iodine Global Network, IGN. We led the development of the materials, but we got input from many experts and many different persons. So it's real pleasure to have you here in this webinar, and we have representation from both UNICEF and IGN. So let me take a moment to introduce the speakers. We have Roland Kupka from UNICEF headquarters in New York. He's a senior advisor there and was really a wealth of experience in nutrition and in iodine in particular, and he's joining us today from New York. And then we have Maouli Sabla, who also works with UNICEF New York and headquarters and is a nutrition specialist, joining us also from New York, and he has also a lot of experience in food fortification, nutrition, and micronutrients. So really happy to have him also speak today. Then Jonathan Gorstein, who is the executive director of IGN. He's speaking from Nairobi, Kenya, but he's based out of Seattle in the United States. And he's an expert in iodine nutrition and with a particular strength in monitoring, among others. And my name is Arnold Timmer. I work with IGN as a senior advisor, and I'm the moderator for this webinar. And I have a long time passion for iodine nutrition, and I'm very happy to be part of this journey. So let us get started. In the next hour, you will hear about salt iodization programs and what has changed over time in those iodine nutrition programs. We will also hear about the implications for what and how we monitor performance of these programs and the impact they make, and what are some of the key recommendations that are in the guidance document, and we will elaborate on that. And then furthermore is how can you use these recommendations in your day-to-day work as a program manager or in whichever role that you play related to iodine nutrition. I have to emphasize that we will not be able to cover all programmatic aspects of iodine nutrition. I know there are many dimensions to this program, but that would take a long time to discuss. We also understand that you will have other questions related to iodine, and we want to hear these, and we can follow up on those separately if they don't fit in the scope of this webinar. We are also considering to set up separate discussion platforms to discuss with you your experiences and questions. so that we can better connect on the work that you're doing. So let me stop here. I would like to give the floor to Roland Kupka to say a few words on behalf of UNICEF. Roland?
Thank you, Arnold. And on behalf of UNICEF and the Iodine Global Network, I would like to welcome you to this webinar on the monitoring of salt iodization programs. I'm also pleased that so many participants have signed up from all around the world, representing governments, donors, development partners, civil society, private sector, and academia. As many of you know, UNICEF and IGN have supported salt iodization as a public health intervention for decades. In 1994, UNICEF and WHO recommended universal salt iodization as a safe, cost-effective, and sustainable strategy to ensure sufficient intake of iodine by all individuals, not just those with evidence of iodine deficiency. And in 2014, WHO reconfirmed its commitment to universal salt iodization. And as we know, thanks to those efforts, iodized salt is now used by many households around the world. To our estimates, 88% of households. And this good coverage translates into the effective control of iodine deficiency in many settings. However, the job is not done, as iodine deficiency continues to affect some 24 countries worldwide and many vulnerable populations in many more countries. In fact, the job will never really be done, as salt iodization programs need to be maintained continuously to avoid the reoccurrence of iodine deficiency. So with this webinar, UNICEF and the Iodine Global Network would like to share experiences and best practices on the monitoring of salt iodization programs, and also with the view towards the fact that we live in a changing world where dietary intake patterns, including those of salt, are rapidly changing. As Arnold mentioned, the content contained in this webinar and the accompanying brief is the result of a true interagency process to which many experts and practitioners have contributed, and which was also supported by funding from the United States Agency for International Development, which we would like to acknowledge here. This is the 7th webinar of this kind, and as organizers, we do hope that you find the information useful for improving ongoing salt iodization programs, and therefore to be able to effectively control iodine deficiency. So again, welcome to this webinar, and I'll turn it back to Arnold.
Thank you very much, Roland. So let us get started with the content side of this presentation of the webinar. So I hand over to Mawuli. Mawuli, the floor is yours. Thank you.
Thank you very much, Roland and Arnold, for those opening remarks, and welcome again to about 59 participants now and counting on. It's really great to see the passion around salt iodization globally. So a few words about the background in terms of the guidance. The program, you all know, most of you participants are aware that previous guidance existed for iodine programs, and you may have come across the WHO, UNICEF, ICC, IDD 2007 guidance on the assessment of IDD and monitoring their elimination. That is a guide to program managers. However, since those guidelines were published, the landscape has actually evolved with regards to salt iodization and IDD prevention. So there was a need to actually update to support countries as their programs mature. So in 2015, a technical working group was actually hosted by UNICEF to discuss research priorities for the monitoring of salt iodization programs and determination of population iodine status. So this technical working group actually consisted of experts and all key organizations that are actually involved in iodine nutrition. And as indicated earlier by Roland, funding was provided by USAID for the development of the guidance. And what were the key objectives of this technical working group? First of all, they sought to identify knowledge gaps related to the monitoring of salt iodization and iodine nutrition programs. Secondly, the group actually aimed to reach consensus on selected issues related to the monitoring of salt iodization and iodine nutrition programs. But an important question to answer first is really why the review was actually necessary. Now, to answer that, this question really was very important to look at the original model of salt iodization. And you would all agree that the original model was actually focusing on the intake of iodine through iodized salt at household level to meet the needs and eliminate iodine deficiency. However, the iodine status was mainly measured through urinary iodine among school-age children. School-age children because this was an easy group to reach and they were concentrated in schools, so it's very often representative samples could be obtained this way. Now, we measured household coverage of salt with minimum iodine level of 15 microgram per kilogram, with the assumption that physiological requirements of 150 microgram per day for iodine can actually be provided through household salt consumed on a daily basis. So if you estimate consuming about 10 grams of salt or 15 ppm, you will be able to achieve 150 microgram requirements. So the intake of iodine through iodized salt at household level can actually help meet the needs and eliminate deficiencies. So we were actually measuring two key indicators: adequately iodized salt at household level and also iodine status of population. The goal was actually to reach or to achieve 90% coverage of households using adequately iodized salt. And the overall impact in terms of achievement is to actually prevent and control. Previously, we've been talking about elimination, but actually, if we don't keep our eye on the ball, countries that are even performing very well can go back into iodine deficiency if these programs are not performing well. So the goal is really to prevent and control iodine deficiency disorders, in particular, goiter, the most obvious clinical symptoms of iodine deficiency. Now, the new program goal is really expanding the scope to see how we optimize iodine nutrition versus the prevention and the control of iodine deficiency disorders, or what previously we referred to as elimination of iodine deficiency disorders. So different dietary sources of iodine now play a significant role when it comes to iodine nutrition. We now know, or we all know now, that the original model of just looking at household intake of iodized salt was overly simplistic and does not fit the reality of today's salt intake anymore. The most important change is that processed foods has become an important contributor of salt intake in our diet, pretty much everywhere around the world. So this salt actually forms a significant part of our total salt intake and therefore needs to be included in the salt iodization approach if we want to ensure adequate iodine intake. Now, we also know that salt from processed foods forms a significant part of our total salt intake and therefore needs to be included in salt iodization approach. And we have observed that iodine appears in rare cases in water or agricultural products. And further, there are other programs, interventions that provide, for example, home fortification with micronutrient powders that is targeting children under 2 years of age, or multiple micronutrient supplementation for women, or specialized food products such as blended foods or ready-to-use therapeutic foods that are used in humanitarian settings or social safety nets. These other micronutrient interventions may not be significant, but can actually fill important gaps, and as program managers, you need to be aware of them. However, we all agree that salt iodization remains the core in the battle to eliminate iodine deficiency, and we need to look at processed foods in our programs. We do not yet have good monitoring tool yet to measure the use of processed foods and with iodized salt, but currently some of these tools are actually under development, and we need to keep the focus on the scale of salt iodization and actually sustain what we have achieved with universal salt iodization programs. So what have been the milestones in iodine programming? When universal salt iodization programs began, the focus, as previously indicated, was actually on providing adequate iodine to prevent deficiency disorders in terms of clinical signs of goiter, particularly in school-age children. Now, in the 1980s, studies have actually shown the detrimental effects of iodine deficiency on brain development. So the focus shifted to all consequences to include pregnancy period. Now, as programs matured and more data on iodine status became available, deficiency decreased, but some programs also reported more than adequate intakes. So as we seek to address inadequate intake, there are other population groups that may actually be experiencing too much intake. So this also has negative effects on thyroid function. So now the focus of programs is really on monitoring that ensures adequate intake for all, not too little, but not too much. So the term is really optimal iodine nutrition. So the need to develop new tools and guidance to better track universal salt iodization programs and assure optimal iodine nutrition is really what we are seeking in our current dispensation when it comes to salt iodization programs. Now, the salt iodization program really, when we talk about in terms of success, what does success look like when we're talking about salt iodization program? First of all, it has to do with the quality of the programs. Iodization levels that complies with standards that are enforced, and also ensuring that these programs has the highest coverage in terms of scale for everyone's iodine needs to be met. And then we also want to make sure we make impact in terms of achieving optimum iodine nutrition. Now, while doing this, we need to make sure that we minimize the population that is deficient, but also we minimize the population that has more than adequate iodine intake. So we need to have a program that is designed and implemented correctly in order to have the right impact. And we depend on data to be able to inform this evidence-based decision-making. So salt iodization is really one of the most successful public health intervention ever. We have observed increase in the number of countries with optimal iodine intake. If we can go to the next slide, we can see this graph that is actually showing how we have evolved with time. So as you can see, the number of countries with optimal iodine intake has actually increased from 8 to 121, and the number of countries declining with inadequate intake has actually declined from 113 to 21 over the past 25 years. It is important to note that the number of countries for which the IGN Global Scorecard has data on iodine status has actually increased from 121 to 155 over this same time period. So the denominator by which we are making this comparison has actually become bigger, much bigger. Now, the next graph is really a very interesting graph, as you can see. This graph actually shows the historical development of iodine deficiency so well. The figure shows the data from many countries in the world 27 years back, so in the 1993s. And there you can actually see that on the horizontal axis, you see the urinary iodine concentration. while on the vertical axis, you can see the Guata rates. The bubbles actually represent the size of the country. So the bigger bubbles you can see there represent China and India. And the colors actually corresponds with the regions of the world for WHO. So you can see the different regions: Africa, Europe, Southeast Asia Regional Office, Western Pacific Regional Office. Now, in 1993, as you can see, we concluded that many countries were suffering from iodine deficiency disorders with very high Guata rates. And the iodine status in the majority of countries was inadequate. So you can see the median urinary iodine concentration is really, really low for these countries, below 100 microgram per liter. Now let us look at the next graph after 24 years, and you can actually see and attest to the progress we have achieved when it comes to salt iodization programs after 24 years. Now you can see in 2017, we have actually shifted from 19 countries where iodine deficient shifted significantly to a very striking progress when it comes to Guata rate reduction. Practically all countries with the exception of a few. So the iodine status has actually improved so much. Now the majority of countries find themselves in the adequate iodine status range, thanks to your effort at national level in ensuring adequate iodization of salt in your countries and across the world. We now only have 19 iodine deficient countries versus 113 in 1993. The outlier blue spots you see there up there is actually Angola, due to some challenges with acquisition of data for that particular country. This impressive improvement is because of salt iodization. It is one of the most successful public health intervention that we have to date. And we can actually say that it is the untold success story, public health success story. There are some countries that are not quite there yet. This makes it very clear that we are not done yet. The job is not finished. And that is why we are delighted to have all of you keeping an eye on the ball in ensuring that we continue to reinforce capacity to be able to ensure successful programs. We need to bring those countries in the iodine sufficient range. Those that are not doing so well, we need to bring them to the iodine sufficient range. But at the same time, we need to ensure that programs that are successful are sustained. We sustain programs that are successful. So let us now take a look at the program steps in more detail. As previously indicated, we want to determine and measure quality, scale, and impact of our program. What is the fundamental goal of salt iodization strategies? The goal is to achieve, and not just achieve, but also sustain optimum iodine nutrition for all. This means that the proportion of people with deficiency should be minimized. But also, the proportion with excess should be minimized. So you are looking at those deficient, but also those with potential of excess. We want to minimize these for different population groups at the same time. So first of all, we need to define our baseline. And the broader circle from there, you can see, just follow the arrow anti-clockwise. We initially define the baseline information by collecting iodine status, which actually expresses the iodine deficiency problems. And then there's a need to address this through program intervention, that is iodization of all edible salt for human and animal consumption. Iodization of all edible salt for human and animal consumption. So in order to achieve this, the salt supply needs to be mapped. And today, as has become more prominent, also the consumption of processed foods. Then, once we define our baseline, we move on to the design of the program. Then, based on the knowledge and supply and consumption, the program is designed. We set the target for salt iodization, and then the type of processed foods to be included, whether it's bouillon, whether it's bread. We actually fix the legislation, regulations, and the way to enforce this. And Professor Gustin will be highlighting some of the processed foods that are of top priority later on in the presentation. It is important also to ensure that there's effective coordination and management of the program and an allocated budget for the implementation of the program. So right after the design of the program, we move into the implementation phase. And there, the focus is really on ensuring that we go to scale with salt iodization for both table salt at household level, but also for processed foods, salt that is used for processed foods. Then ensuring effective utilization in terms of the utilization in the form of table salt, but also in the form of industries that are using iodized salt in processed foods. Then, of course, we go back onto the broader circle where we try to look at impact and continuous monitoring and evaluation of our programs. So in the monitoring of programs' effectiveness and impact, we address all, we actually focus on addressing all aspects of the program's monitoring. The quality of iodization needs to be monitored through checking iodine levels along the supply chain at production, importation, export, processing, and also at market level. And we actually need documented operational procedures for industries, for external regulators to be able to do this effectively. We monitor at scale, not just the quality, but also the scale is also important. And then it is important to determine the extent to which the program has been implemented. And then we move on to assessing the coverage. We look at feedback mechanisms on the household that are using iodized salt and the targeted food industries that use iodized salt in processed foods. Finally, we go on to the impact level when we want to see concrete change in terms of programs showing effectiveness among vulnerable groups, school-age children, pregnant women, and women of childbearing age. It is important to determine the magnitude of deficiency, but also to ensure that we address the issues around excess. So what can we monitor? How does this data that is collected through these processes assist us for evidence-based decision-making? Data can actually help us to improve compliance of salt producers to iodize their salt according to the standards. It can help us to expand salt iodization and the use of iodized salt by food industries. It can help us to identify problem areas where the coverage is low. It can actually help us to know if the salt iodization standards are correct and if we know the iodine status among those that are using the iodized salt. And then it can also help us to assess in terms of our goal of optimum iodine nutrition is being reached, and also adjusting the programs as needed to ensure that we sustain our achievement. So given this background, what were some of the key recommendations which emerged from the expert meeting? And how do these align with the monitoring and program needs presented just now? Using this program model, we will now explain the key recommendations from the guidance documents. Now, the first one is really the correct use of rapid test kits. In the program model, we see that rapid test kits have been used for monitoring quality at the supply and also at the market level, and for assessing coverage. They are also used often for education purposes at schools or by consumer groups to check if the salt they are buying is iodized or not. Now, when we go on to the next slide, you will see the rapid test kit, and I believe most of you have come across the test kit in your programming work. Now, as you can see, the rapid test kits are shown here. is commonly used in terms of assessing whether iodine is present or not. There are three different options shown here. The white is salt without iodine, and then the light blue is salt that is iodized below 15 ppm, and the darker blue is salt that is iodized above 15 ppm. Now, the rapid test kit, it's a chemical solution, a combination of acid and starch that reacts with iodine, turning it blue. That works by putting a few drops. So you go out there, you drop a few on the salt, and you can actually see the color change. Now, when there is iodine, it turns different shades of blue. It is known for its ease of use, and therefore it is actually field friendly. And most of you have been using this in the field. Now, this device depends on observed change. So it is really subjective as measured by the human eye. So it is only good enough to tell if there is any iodine in the salt. It has also been incorrectly used, and a lot of program managers have used this incorrectly to distinguish inadequately from adequately iodized salt. This is not the objective. And multiple studies have shown that the rapid test kit is not suitable to determine the amount of iodine in salt, whether it's adequate or inadequate. Rapid test kits, therefore, should only be used to differentiate between non-iodized and iodized salt, and not to measure the actual iodine content. If you want to determine the exact amount of iodine, used titration, the WYD checker machine, or other available quantitative analysis that is out there. If you only want to test the presence of iodine, then the test kit is still very suitable. So the bottom line is we need to use the method for what it is designed for. Now, let us move on to the second recommendation. This recommendation, and this is the last recommendation I'll take, and then I'll hand over to Professor Gustin. This recommendation is looking at the acceptable range when it comes to urinary iodine concentration in monitoring iodized salt programs. Now, in the program model, we see that this recommendation actually relates to the assessment of iodine status and is important for evaluating the impact of salt iodization and ensure optimum iodine nutrition for all. Now, let's explain this recommendation using some study that was undertaken in 2013. We know that median urinary iodine concentration is really a biomarker of iodine intake for school-age children in the past. Now, in the past, the median urinary iodine concentration in the range of 100 to 199 microgram per liter was judged as adequate iodine intake, and the range of 200 to 299 microgram per liter indicates more than adequate iodine intake among school-age children. This was done by WHO. Now, this range was an estimate and was never grounded in the functioning of the thyroid gland or the negative consequences of the function of the thyroid gland. So in a 12-country study, the association was assessed between urinary iodine concentration and thyroid function among 2,500 school-age children. So what was the conclusion? Over a range of iodine intake from severely deficient to excessive risk of thyroid dysfunction, increase in children with iodine deficiency, and that is urinary iodine concentration below 100 microgram per liter, and iodine excess urinary iodine concentration above 300 microgram per liter. However, in the ranges of 100 to 299 microgram per liter, the thyroid function was judged normal. This means that there was no difference between the 100 to 199 and the 200 to 299 microgram per liter range. Therefore, the two ranges were actually combined or merged into one. So currently, the acceptable range of median urinary iodine concentration in monitoring iodized salt programs is safely widened to between 100 to 299 microgram per liter. This is very important because it is important when trying to bring other population groups like pregnant women who have higher requirements into an adequate range while not pushing school-age children into excess. This study has actually shown that the room to maneuver is much, much larger than we previously thought it was. So I would now actually hand over to Professor Gustin to take us through the other 4 or 5 key recommendations and then conclude with this webinar. Over to you, Dr. Gustin. Professor Gustin.
Thank you very much, Mawuli, and greetings to everyone who's on this webinar. I'm going to go ahead and just go into the use of urinary iodine with a little bit more granularity and detail. And it's just, again, really important to understand that urinary iodine concentration has been an incredibly effective metric to be able to track iodine status, both in terms of establishing the baseline of the program and tracking changes over time. But it's really critical to really emphasize that with currently available methods, the analysis and interpretation of urinary iodine concentration can only be used at the population level and to define population iodine status. And it cannot be used to estimate the proportion or the prevalence of the population with iodine deficiency or iodine excess. And that's really because the concentration of iodine excreted in urine is an indicator of intake, and individuals' intake can vary quite significantly daily or even within the same day. While these variations can tend to even out within populations, they provide a very useful measure of the overall iodine status of populations. The assessment of urinary iodine is typically assessed from a single spot urinary specimen that is collected at one point during the day. And because of this variation in individual status, UIC data can only be presented for the entire population, presented as the median value, and it cannot be used to classify individuals in terms of their individual iodine status. As such, the median value provides an overall reflection of the status of iodine nutrition for the entire population. The use of percentages of low and excessive iodine intake has been used in the past and has actually been problematic and leads to misleading impressions or interpretations of what the iodine nutrition status is of populations. A common practice, and I saw this just in reports that are being analyzed in the last few days, is to label the percentage of those whose values are below 100 micrograms per liter as deficient. And this is methodologically incorrect for the reason that we can only use the median value. So for an example, when the median value is less than 100, is greater than 100, implies that the entire population's intake is adequate and optimal. There are examples where a population whose median value is 120 micrograms per liter, but individual UIC values below 100 may be 40% or more. And we really can't label these as being deficient because they belong to the very same population, which is being classified as having optimal intake based on the median value of 120. Therefore, it's really, really important that we don't classify different segments of the population or proportions of population that are falling below different cutoff points, above different cutoff points, or within different ranges. The median value, based on our currently available tools and methodology, is the most appropriate and foolproof way to present the iodine status of populations. This table provides an overview of the current iodine status categories, those that are insufficient, adequate, and above requirement as recommended by the World Health Organization for different population groups. And while we have really focused on school-age children in the past, increasingly we're recognizing that it's important to assess the iodine status in women of reproductive age, as well as pregnant women where possible, because these age groups provide us not only with an impression of their status, but also of the protection of the unborn children to having adequate iodine status. For purposes of comparisons, many countries do continue to measure school-age children, but where possible and resources allow, it would really be helpful to begin to get more data on the status of women of reproductive age pre-conception to be able to get a better sense of whether or not salt iodization programs are actually positively impacting the next generation of children. The fourth recommendation is also related to the assessment of iodine status using urinary iodine, and really is based on the question of whether or not it's okay to just measure iodine status in one population group alone. It's important to note that an adequate status of one group may in fact not mean that the iodine status is replete or adequate in all age groups. This is really important for pregnant women whose requirements are higher and in whom we'll all agree their iodine intake is absolutely essential to ensure. So this is just an example of a situation where a survey was undertaken. The main target group were school-age children, and the median urinary iodine concentration level was 163, which falls right within the range that Mwuli was describing as being optimal, 100 to 299 micrograms per liter. In this particular case, the country would come to the conclusion that the iodine status is adequate and that the salt iodization program is meeting all of its objectives. However, in the same survey, the country also collected data on pregnant women and noted that the median urinary iodine concentration in pregnant women was only 113 micrograms per liter, which is actually below what is considered to be the optimal range of 150 to 249 micrograms per liter. So in this case, the conclusion is a little bit different. While the school-age children iodine status seems to be adequate, the intake of iodine through the salt iodization program is not meeting the needs of pregnant women. So in this country, they did a little bit more work. They looked at the iodine content and iodized salt, and they realized that it was too low to meet the physiological requirements of pregnant women and made appropriate programmatic adjustments. So the conclusion and the recommendation is that an adequate iodine status for one age group doesn't necessarily guarantee that the iodine status will replete and sufficient for all other age groups. So where resources permit and where it's possible to assess iodine status in multiple age groups, this provides more granularity and more information on the performance and the impact of salt iodization programs. The fifth recommendation, again, has to do with how we analyze and interpret and present data on urinary iodine concentrations. And here we really just want to emphasize the importance of going beyond national aggregate estimates, a single national figure, and understand how different subgroups are performing. And we know that national level data are super useful to track overall progress. They're used in our IGN global scorecard, but they may in fact hide disparities and other subnational variations. While many countries are currently classified with adequate iodine status, there may be subpopulations with suboptimal iodine intake, and these populations would be unprotected against the consequences of iodine deficiency. So by doing stratified analysis and undertaking some subgroup analysis, it's possible to identify some of these disparities and gain information where programmatic enhancements are needed and will be helpful. So just as an example of how important this is these are data from a country survey. These are real data. And as you can see, the overall coverage of household iodized salt is 83%. So the combination of 33%, which is inadequate but still iodized, and 50% classified as being adequate. So 83% of the population has iodized salt, but only 50% of that salt is adequately iodized. And in the same population, the median urinary iodine concentration level is 130. So looking at these two main parameters, the ones that we sort of focused on at the beginning of salt iodization programs, the original paradigm that Mwuli alluded to, in fact present a little bit of conflicting information, and it's unclear how well the program is actually performing. And it does mean that we're not providing the granularity and the level of detail that's necessary in order to really understand what is taking place in terms of the program. But when we're able to go a little bit deeper and undertake further investigation, we can get a little bit more information about what's going on with the program and how we can interpret these two indicators together. So this table provides a very, very simple stratification where we look at the median urinary iodine concentration level by varying levels of household iodine content in salt. And as you can see, amongst those households with no iodine in their household salt, 17% of the population, their median value is 78 micrograms per liter, clearly reflecting that they have suboptimal iodine intake. And in the other two groupings of those households with inadequate iodine or adequate iodine intake, the median urinary iodine levels are quite a bit higher. So the conclusions and really what we can take from the interpretation of this kind of data is that this country really needs to improve the quality of this iodization, reduce the number and the proportion of households that don't get iodized salt. We get a sense that probably the iodization level is correct because the median urinary iodine level for those getting the right level of iodized salt at the household level seem to have sufficient iodine status, and that probably iodized table salt in this population is a main source of iodine in the diet. Because if in fact your processed food salt was a major source contributing iodine to the overall diet, even those households with low iodine in the household salt would have optimal iodine status or a higher median urinary iodine level. Another way of looking at median urinary iodine levels that's stratified is by really considering whether or not there are differences by socioeconomic status or by wealth. Often we see that poorer segments of populations will buy less expensive salt. This tends to be from small producers. It tends to be crude salt, not more difficult to iodize adequately. So in this particular example, which is nationally representative data from the Philippines, where they stratified data on the iodine status by wealth categories, you can clearly see that the poorest households were those that were most vulnerable to iodine deficiency and whose iodine status was classified as being suboptimal. So what we really recommend is that you consider doing some stratification and some subgroup analysis, and don't rely only and exclusively on a single national figure on the median urinary iodine concentration level. So again, where resources permit, to enable sampling to look at differences in urinary iodine concentration by location, by region or state, economic status, or salt iodine content, provides additional information that helps identify groups within countries that may be vulnerable, that may not be protected, and enables program managers to target resources more efficiently and more effectively where there will be the greatest possibility of bringing all groups up and enabling optimal iodine nutrition. The sixth and the final recommendation, which emerged out of the consultation, was really just recognizing the importance to be more inclusive in our overall USI programs and consider the use of iodized salt in processed foods and condiments because of the fact that these salt consumption patterns have changed, and we need to understand where the salt is in our diets, and that all salt should be adequately iodized, not only that the salt that is intended for discretionary use at a household level. So by understanding the different sources of salt in the diet and whether or not these are iodized, enable us to get a much more robust understanding of the inputs that are leading to iodine intake and in turn population iodine status. So while we still really want to focus on the overall program performance of salt iodization programs being the iodine status, we do believe that getting additional information on some of these major inputs is important. In general, we recommend that the first focus should be to get an estimate of the coverage of iodized salt at the household level. Continue to do this, to use a rapid test kit to get an overall estimate of whether or not the salt reaching households is iodized or not. This indicator of the proportion of households using iodized salt, it continues to be a major indicator to track salt iodization programs included in the UNICEF global database. But in addition, it could be helpful to begin to understand the other main sources of salt in the diet, including those in processed foods and condiments. We know that the major sources that these include, I have to go ahead and take the presentation back over, I'm sorry. All righty, sorry about that. So we know that if we can understand what the major sources of salt are in the diet, such as bread or instant noodles or condiments, we can then also look at whether or not the salt that's used in the manufacture of those products is in fact iodized, and how much iodine that could be contributing to meeting iodine requirements or overall iodine intake. In this next slide, we've done a bit of analysis at the Iodine Global Network together with partners to really begin to understand what is the potential contribution to iodine intake that is coming from the iodine in iodized salt in processed foods. And in this table, you see that there are certain major commodities, major suppliers of salt in the diet that if the salt that is used in their manufacturing iodized could contribute significantly. So baladi bread, which is widely consumed, particularly in lower income households in Egypt, has a very high level of salt. That salt is iodized, and because the per capita consumption is very high, it contributes about half of the total iron requirement in the diet. In other countries like Indonesia, the major sources of salt vary. They include instant noodles and soup stocks. And we've come to really appreciate and learn that condiments, particularly seasonings such as bouillon cubes, can be a major provider of iodine in diets if the salt used in the production of bouillon cubes is in fact iodized. So from studies in Ghana and Haiti, we see that while households' iodized salt coverage is very low, iodine status is in fact quite optimal because of the fact that the consumers use bouillon cubes ubiquitously, and the amount of salt that's used in bouillon cubes tends to be high, and that salt is iodized. Now, what's also really important as we begin to look at the iodine intake from processed foods and condiments is that we remain cognizant of the important synergy between salt iodization programs and salt reduction strategies. As we look at overall salt consumption patterns, it's important to be mindful of the fact that we're making sure that the salt that is currently being used is iodized, but we don't encourage or in any way promote an increased consumption of salt in order to realize iodine nutrition aspirations. So I've gone through a couple of the final recommendations to supplement what Mawuli was able to share. We're super excited about this guidance because we feel as though it will really encourage countries to fine-tune their program through having more robust monitoring data that provides a little bit more detail on not only the iodine status, but on the sources of iodine in the diet. We've shared 6 key recommendations. There are additional recommendations and additional details provided in the actual guidance document that is available in English and French and Spanish and Russian. We really encourage you to share this information with other stakeholders that you're aware of. We are excited about the opportunity to have presented these webinars, as Arnold presented at the very beginning. The transcripts of the different webinars in different languages and the webinar guidance itself in different languages is available on the IGN website. But this all, is enabling us to fine-tune our programs as they mature. We're incredibly grateful to the support that we've received to be able to carry out this work and generate new guidance, in particular the contributions from the Gates Foundation, from GiveWell, from the U.S. Agency for International Development, and of course Kiwanis International. So we hope that that you've been sending some questions into Arnold. I'll go ahead and turn the floor over to Arnold so that we can try to address some of those questions. But again, from my side, thank you very much for participating. And Arnold, I'll go ahead and turn the floor over to you to go through any questions that have been raised. Thank you.
Yes, thank you very much, Jonathan. I'm just trying to get access to my slides with the questions. Can you see them now? I don't know.
You'll have to share your screen, Arnold.
Okay, I have trouble with that. Okay, so let's go through the questions. Somehow I can't share my screen. Maybe Jonathan, I quickly sent you the PowerPoints. But let's get started. There are a number of questions on processed foods. Well, I'll send this to Jonathan. Excuse me. Technology. Okay, so questions on processed foods. Is there any study on the contribution of iodized salt in processed food? From Rosie. I think what you meant is there any study on the contribution that iodized salt makes into the total iodine intake? I guess that's what you mean. So let me take this first question. Yes, there are quite a few studies that have looked at that, and the general approach is to look at the food intake of the population, the food consumption data, dietary intake studies, and then identify those food items that contain salt. I identify the amount of salt in those food items and the consumption of those foods. And then you can translate it into the actual potential iodine intake that those foods can make in the total iodine intake. So that's, I think, the short answer to that question. Oh yeah, Jonathan, you have them on. Great. So the second question, and I'm also asking Jonathan, Maruli, and Roland to answer some of these questions. The second one is currently processed food are the main source of daily salt consumption. That's correct. In many countries, that's the case. Therefore, it is recommended the use of iodized salt in processed food is mandatory through a recommendation to countries to include this in your laws and regulations. Yes, that's very much when the approach is to include iodized salt in processed foods, which is necessary in those countries and in those places where processed foods form an important part of the diet, which is almost universal now. Yes, it should be included in your laws. We see that many of the laws do not yet specify this, and this is one of the attention points of IGN and other organizations to focus on this and to specify which foods and the levels of iodine. The third question, salt iodization in processed food is a good idea, but maybe a challenge as it needs cooperation from producers. So this question, that's indeed very, very correct. And I think this is bringing the important point that we cannot work without the private sector. We need to engage with the private sector in discussing what is required to make a shift from iodized salt, from non-iodized salt to iodized salt. What are some of their barriers that they may experience? What are some of their perceptions? Some of their perceptions may be based on facts. Some may not be based on facts, which I have experienced a lot in the past. So you need to address those, and they need to be on board. They need to be comfortable, because at the end of the day, it's their product that they're selling, it's their business, it's their livelihood, and the livelihood of their employees. So it's very important. But studies have shown, all the scientific studies, that iodized salt can be used in processed foods. There's no negative impact on the quality, on the texture, on the taste, on the appearance. And the majority of the foods, it's actually the case. Maybe Jonathan, do you want to take a few of the next questions? And then we can move to the next slides.
Sure. I actually just want to respond initially to Sergio's really excellent comment. It's the second point that was made that, I think we have to be very clear about what we're talking about when we talk about universal salt iodization, which really is the iodization of all edible salt, meaning both that salt that's used in households as well as that used in processed foods. Sergio is actually writing from Mexico, and there are some threats in some countries right now where there are some salt producers requesting exemptions from mandatory salt iodization for certain types of salt, not only the salt that's used in processed foods, but also certain boutique salts or artisanal salts that are considered in high demand for culinary applications. So these are flaky salts that have high proportion of impurities. And as a community, we just have to understand that one of the real drivers of the success of universal salt iodization has been the fact that we've been able to make this mandatory. Jenny asks whether or not there are, in fact, examples where iodized salt used in processed foods and condiments is specifically mentioned in legislation.
Yeah.
We reviewed this. We understand that, as Arnold just mentioned, it is not explicitly mentioned in some, but very, very few national laws and regulations regarding salt iodization. So as such, it is a loophole, and therefore the food industry does not have really clear guidance, let alone compulsion, to use iodized salt in the manufacture of their products. There are many countries that are now looking at targeted food products and certain food industries to use iodized salt in the production, such as only in bouillon or soup powders, or such as just in bread, which is in the case in many industrialized countries. And I know that there are some participants on the call right now from Israel who are also looking at whether or not to make the use of iodized salt in the manufacture of certain baking products and bread mandatory in that country. So I think that, and just a final question on this slide before I go forward, is that we, are currently looking at better data on the proportion of countries, the number of countries that are using iodized salt in processed foods. But in fact, it's not been routinely monitored. And the very reason for this guidance is to encourage countries to think a little bit more broadly about how they can better monitor their iodine intake populations, and incorporating into that monitoring an element where countries begin to look at what are the major sources of salt in processed foods and condiments, and whether or not that salt is iodized or not. So we do hope that we'll be able to mention the total number of countries, but it will require a shift in terms of the design of monitoring and the metrics that are used to assess national salt iodization programs. Arnold, I'll go on to the next slide, and maybe we'll have Mawuli or yourself respond to some of these next questions, okay?
Yeah, so I'll read the question. How could countries feasibly and reliably estimate and monitor the estimated daily per capita intake of salt? Actually, maybe Jonathan, do you want to take that question? And also related to that assumption that the salt intake is 10 grams per person per day. But yeah, the intake of salt, yeah, go ahead.
Absolutely, and Abe, if you want to actually take yourself off mute, maybe you can also offer as well. But one of the things that we in the Iodine Global Network are also really trying to do is better align our work and our monitoring with those who are working towards salt reduction. So the communities that are concerned about the risk of excessive salt intake and on non-communicable diseases do quite a bit of monitoring of urinary sodium and amount of total salt intake in the diets. And we've been able to develop some common guidance and begin to undertake joint monitoring in a few countries so that we can begin to, as you say, Abe, more reliably generate estimates on the actual per capita intake of salt in different countries. Going one step beyond that, measuring either urinary sodium from 24-hour urinary spot specimens or from spot specimens, and using additional indicators that will allow us to use models to estimate the salt consumption. We're also very interested in generating some very basic data on the different sources of salt in the diet. So the Institute for Health Metrics and Evaluation, which generates a global database on salt consumption, the George Institute, which is really one of the leading groups working on salt reduction, collect very, very good data on per capita sodium intakes. But what they have not been able to do reliably, and which they're very keen on doing, is understanding where that salt and where the sodium is actually coming from. So what we're doing is being more purposeful in our alignment and our collaboration with these groups. And what we do hope is that we can generate guidelines that will enable countries to jointly monitor both urinary sodium and urinary iodine to basically answer some of these questions. And in fact, it will help us answer the next point that Dr. Chandrakant Pandav makes, and that is that for so long we've assumed that the per capita salt intake is 10 grams per person per day, and we've set our salt, our iodine content standards based on that per capita level. But as we fine-tune programs, as programs mature, as salt reduction programs are implemented, we do need to understand whether or not this assumption of 10 grams per person per day is in fact accurate, and if not, to use that information to adjust standards in terms of the iodine content in salt. Back over to you, Arnold, or unless Abe or anyone else would like to chime in. Otherwise, to you, Arnold.
Yes, thank you. Maybe I give the floor to Maruli for the next few questions on. So I think it's also important to mention the importance of adding iodine to artisanal salts and gourmet salts, because consumption of this type of salt has grown in all countries. What do you think? And the second question is, will be important to discuss voluntary versus mandatory iodization to avoid excess through market-driven iodization, and recurring monitoring with provision to resetting standards. Maruli?
Yeah, so the first question on the iodization of artisanal salt. I mean, more and more we believe that consolidating the salt industry allows us to have higher reach and higher coverage of adequately iodized salt. It's very difficult in most contexts and challenging to work with very small scale artisanal salt producers. Also because the homogeneity of the iodization process and even the reach, it's very minimum, and they usually produce coarse salt. We do understand that there's a significant penetration in some countries. And what we are proposing is to see how, for example, in the case of Ethiopia, they have succeeded in centralizing the iodization facility and able to procure salt from small artisanal producers and ensure a centralized iodization process, which then allows us to have more higher reach and more effective salt iodization. Now, it will be important to discuss voluntary and mandatory, the next question, on iodization to avoid excess through market-driven iodization and recurring monitoring. Of course, certainly the approach of ensuring universal salt iodization is to make sure that we make impact in reaching a significant proportion of the population. But within the context where you want to avoid non-iodized salt reaching some proportion of vulnerable population, we would say we would discourage voluntary salt iodization and rather promote universal mandatory salt iodization, which is really a strategy that we want to continue to advance to reach the most vulnerable within, especially in low and middle income countries. So for this particular aspect of the importance of discussing voluntary versus mandatory, I think we are really pro mandatory, and that's how we should continue to advance this agenda, and also ensuring that even salt for animal consumption is also iodized, also because in most of these countries there's a lot of porous, the regulatory systems are already not so strong. So if you want to begin discussing issues around voluntary, then you might not be making the impact that we're seeking to achieve. So of course, Jonathan has already made reference to the fact that the 10-gram assumption was really in the past, the thinking of around that, but now the discourse is really how do we balance adequate salt intake with adequate iodization. So you don't want to exceed the WHO recommendation, for example, of 5 grams of salt per day, but you want to ensure that the quantity that is being consumed is adequately iodized based on the standards within countries.
Okay,
over to you, Anne.
Yeah, next, go one slide back, Jonathan, please. You skipped, yeah. So on the rapid test kits, can't rapid test kit identify adequately iodized salt even if the color turns dark blue? That's a very good question, and this has been a debate for a very long time in the community and the scientific community. But all the studies have shown that, and we have to the public, we'll share the publication with you, the reference, that is actually not the case. Judging a color is very subjective, and also we also see that often the type of salt influences how long the color stays and if it disappears again or when it actually appears. So the answer is no. It cannot identify between adequate and inadequate. where can we obtain a rapid test kit to share with colleagues, friends, and national health authorities? I recommend you can procure these if you go to the UNICEF website. You can see who produces it, the test kit, in if you want to use it for really for the purpose that it's designed for. Does the rapid test kit work on low sodium salt that are currently in the market? Actually, I don't think it makes a difference whether it is low sodium salt or other type of salt. You basically work irrespective. So unless somebody else has another opinion on this, then on iodine intake, I don't know if Jonathan or Roland, if you want to take some of these questions. Otherwise, I can continue. So the question is clarity on optimal iodine intake for the prevention of endemic goiter and endemic cretinism. Yeah, I think
I'll go ahead.
Yeah, go ahead.
Yeah, no, thanks, Arnold. I see, Dr. Pandav, that you also asked about excessive iodine intake. I think that the big thing is that, early on, we were really focused on trying to make sure that there was some iodine, enough iodine in the diet in order to really contribute to iodine sufficiency and prevent, any problems related to goiter and cretinism. And our focus was really on getting that minimum level. And as we began tracking an increasing number of countries in terms of their iodine status, we began to identify countries whose iodine intake was potentially too high. WHO had a classification of excessive iodine intake that could potentially lead to adverse consequences in terms of thyroid morbidity and other adverse effects. So they said very clearly a cutoff point of 300 micrograms per liter. If a median value exceeded that value in school-age children, it suggested that the iodine intake in the population was too high. And as we began to see countries like Brazil, like China, and others whose iodine status was in fact classified as being excessive, we realized that we needed to just prevent deficiency to achieving optimal iodine intake, to reach that sweet spot, if you will, of having enough iodine, not too much iodine in the diet. And this has just required a fine-tuning in terms of the way that we analyze and interpret and present data on iodine status in populations. The definition of excessive iodine intake using median urinary iodine concentrations is in fact included in the WHO publications back to 2007. So, we know what those cutoff points are for pregnant women. It is 250 micrograms per liter. For school-age children, what we're currently using for women of reproductive age, that cutoff point is 300 micrograms per liter. So where the median value exceeds that value, it's suggestive of the iodine intake being too high, and it enables program managers then to make adjustments. Arnold, I'll go on to the next slide, and then maybe you can continue.
Yeah, there's also another question that is not listed here, but that is in the chat box by Omar Dari. You suggest that we should emphasize that to measure the iodine in salt, for example, through titration, that you need sufficient salt to do that. If you take a very small amount of salt, then you can, the error is quite big that you don't get to the true value. So I think that's another aspect to keep in mind. Then on iodine status, how can we define inadequate iodine status in different age groups? What methods do we use? Well, we have seen that iodine status and the relation to thyroid function has been established for some population groups, especially I think for school-age children, and if I'm not mistaken, for pregnant women. They are under development also for other population groups. So iodine intake I'm talking about. So that actually is then so directly linked to a functional marker, and that's important because that's the assessment and the definition of adequate, inadequate doesn't just come out of the blue. So that's what I want to say about that. The second question is about the cutoff points, and this links to the distribution curve of urinary iodine, which is a population indicator. So, and we have mentioned in this webinar that you should not look at the values below 100 because that's not a correct thing to do. However, it's also mentioned that not more than 20% of samples should be below 50. I think the point here is that we need to look at the curve itself. We need to look at the shape of the curve, actually visualize the curve and see whether this is actually quite a curve that fits a normal distribution, or if the curve is actually composed of different curves, so different populations and different exposures. So you could, if you see different lumps in the curve, more on the lower end, on the high end, then as compared to what's normal for this indicator, then you should actually look more carefully whether you should do subgroup analysis. So I think this 20% of samples should be not be less than 50 microgram per liter. It's just basically to say, look at the shape of your curve. And I don't think we want to go down and look specifically at the percentage of your population below a certain cutoff level and define them as deficient. That's not correct. You need to still look at the median of the entire population, but look at subgroup analysis, as we mentioned. Could we have interpretation on how to approach the cutoff suggested of 20%? Okay, that's the point I already discussed. Should trimester of pregnancy be considered when assessing median urinary iodine concentration among pregnant women? Actually, I'm not really informed about how to deal with this. I don't know if Jonathan or somebody else wants to answer this question.
I'll give a crack at it, and I would love for maybe Omar to chime in as well. You know, obviously we know that there are changes in iodine nutrition over the course of gestation, over the course of a pregnancy. But in general, Abe, what we've found is that it's really, really difficult to even capture a sample of pregnant women to be able to measure the iodine status in pregnant women. So as such, we haven't really come up with guidance to focus only on the first or the second or the third trimester. You know, to be able to capture those data would be challenging in terms of operations. Having said that, Abe, one of the things that IGN is really keen on exploring right now is to generate more ongoing data on iodine status in pregnant women through leveraging antenatal clinic surveillance systems. So this is something that you, I'm sure, are quite keen on and interested in, and that is that, you know, with the high rates of antenatal coverage in many countries, women come in, their time of first booking tends to be within the first trimester of pregnancy, somewhere between 12 and 14 weeks of gestation. And if during that first booking, as part of their assessment, they can provide a urine sample, that urine sample can then be analyzed, it may be possible to use antenatal clinics as a routine surveillance platform to generate continuous data on iodine nutrition in countries. So we're about to pilot this approach in Sri Lanka. There's interest to explore this in other countries as well. And if in fact we do that, we could probably be a bit more specific about during what stage of pregnancy or at what stage of gestation the urine specimens could be collected, because that would in fact enhance the interpretation. Omar, I just wanted to provide you, if you're still online, with any thoughts or comments you may have for those who are considering measuring pregnant women as part of large surveys, the extent to which they should consider looking at the stage of pregnancy as being an important element for their survey design.
I think Omar Dari has left the call. Hi, this is Roland. I mean, just to say that there is work ongoing to justify the range that we've been using to classify adequate iodine status among pregnant women, because there are still some gaps in the evidence. So what we hope is that later this year, Publications will be forthcoming to specify exactly what the optimal range is for pregnant women. And I hope that that research can then also specify whether there are any differences that need to be considered by a trimester of pregnancy.
Perfect.
Yeah, and maybe
go ahead.
And maybe let me take some of the other questions with regards to ensuring the quality of the fact that the common salt that is used for iodization is also monitored, Dr. Pandav, and also the need to focus on training of salt manufacturers and iodized salt producers, and the importance of ensuring the quality of potassium iodate in the monitoring process. So Dr. Pandav, I mean, these are rightly questions in terms of the operational processes that are required to ensure that our salt iodization programs are being effective. And one of the challenges we've realized is that most industries do not even have like documented operational procedures or even equipment maintenance in terms of the equipment that is being used for the iodization processes. They are not maintained appropriately. They are not calibrated appropriately. So definitely we should continue training these industries, and we should continue making sure that they have documented operational procedures in place. They have capacity to be able to continue to do analysis regularly, so that even when you change staff, the procedures are there for new staffs that are employed to be able to follow through to ensure that things are done consistently. This is the only way we can ensure that, you know, the processes, the procedures, the maintenance systems are in place at the industry level to ensure quality iodization processes. And having said that, the point that Omar made earlier on with regards to even the sampling in terms of the quantity of salt, but also even the particle size of the salt that is being iodized can also influence even some of the results when it comes to determining the iodine levels in the salt. And also the quality in terms of moisture levels and all the other quality parameters can also be influencing the iodine levels in the salt, and the way it is packaged, the way it is put on the market, and the consistent monitoring of the salt throughout the value chain from the factory level to the market level. There has to be continuous capacity development to ensure that we track the quality parameters and the procedures and the capacity development of those involved in all those processes.
Thank you, Mawuli. The last slide with questions. Well, there are some more questions in the chat box. I would like to first discuss the second bullet, which is on the recommendation that campaigns to decrease salt intake also mention the benefits of adding iodine in salt. I fully agree, and I think this is something we didn't talk about much in this webinar, but it's very much on the in the mindset and in the program approach of the iodine community. We fully think that some of the program approaches should really be aligned and combined. Salt reduction efforts deal with processed food industry. They assess the salt that comes through there. They work on reformulation. Well, iodine is part and parcel of that. So combining these efforts makes a lot of sense, and I think also raising the awareness and informing consumers about this needs to be combined. That's really essential. The first question, are there examples of countries with suboptimal iodine nutrition status that have legislated mandatory iodization of processed food and condiments? I'm sure there are countries that, I don't know if you meant that they only mandated of salt for processed food and condiments, but not for table salt. But in some of the examples that we see is that countries are dealing with a set of menu options and trying to design their own approach in terms of iodization level, in terms of which foods to include. Of course, the most common and the easiest to monitor is the universal approach and mandatory approach of all salt. But there are indeed examples where they have done this through specific foods and not achieved the goal. I think mainly some countries in Western Europe fit this question. The sentinel site surveys, the third question, considering introducing sentinel surveys among vulnerable groups, poor and poorest groups for sampling annually. I think this is indeed the future, or already the presence in some country, but sustainable monitoring, I think, is very important. We see that many of the monitoring approaches are costly, very slow in returning the data for decision making, and we definitely need to go to very light and rapid turnaround of data to adjust your program and inform the program managers. So yes, very much on our agenda too. Maybe Jonathan, do you want to tackle the question on India and on the last question?
Sure. Let me go ahead and read that fourth bullet out loud. It was actually one of two major national micronutrient and iodine surveys conducted in India, and the iodine survey conducted by Nutrition International primarily showed that there were variations in household iodine salt coverage in terms of adequate iodine salt and population level iodine coverage. I assume that's population level iodine status. So I'm not actually sure of the question, because in fact, if there were variations in household coverage of adequate iodine salt, then then this would actually lead to differences in population iodine status. My question from IGN would be to know, by when do you think some kind of tools would be available to the wider nutrition community? And the absence of the same, should we not use the population iodine status as primary indicator of assessing iodine programs at the country level? Thanks. With all respect, I'm not sure I exactly understand the question, but let me just go ahead and give a crack at it. What we really are proposing in the guidance document is that by doing subgroup analysis, it allows us to get additional granularity on the salt iodization program in terms of its performance and where there both have been successes and where there may be gaps that require additional resources and intervention. In the case of one of the slides that I showed, we see that there is a close correspondence between the iodine content in household salt and the median urinary iodine concentration in populations. And this information basically concurs that household salt is still a major contributor to the iodine intake, and that efforts should be made to increase the availability and the quality of iodine salt that's making its way to households. By doing the same analysis in other countries, we found that the median urinary iodine concentration level, even amongst households with low iodine content in household iodine salt, is quite high. And I use the example of both Ghana and Haiti. And that information provides insights as to the fact that there are other sources of iodine in the diet. So while household iodized salt may not be adequately iodized, that populations are getting their iodine from elsewhere. And this compels us to then look at other sources of iodine in the diet, and our main focus has then been on the use of iodized salt in processed foods and condiments. And I mentioned in Ghana and Haiti, the primary condiment that was implicated was bouillon, in which 40 to 60% of its composition is salt, and that salt was iodized. So just in terms of guidance, the IGN has developed new program guidance on the use of iodized salt in processed foods and condiments to provide additional information on this very important programmatic element. But I just want to say that while we do have guidance on that, we don't really encourage countries to go in and do really elaborate dietary intake surveys of all sources of salt, but really look at the 2 or the 3 main sources of salt in the diet, whether that are included in processed foods and condiments. Is the salt that's used in the manufacture of those products iodized or not? And that really will help paint a broader picture and a better understanding of what's really driving iodine intake in populations. The final question is actually one that we really struggled with, and it's not only pertinent, the minimum sample size for stratified subgroup UIC analysis, but just what is the minimum sample size to get a robust median urinary iodine concentration estimate at the national level. And the guidance document does go into some detail about this. And as you can see, we basically recommend that a minimum sample size of approximately 300 urine specimens is really necessary in order to generate a median value with a relatively tight level of confidence or variation around that median estimate. So this is, just the reality. You can reduce the sample size, but when you do so, so does your precision decline, and therefore the reliability of the estimate decline. And we're aware of the fact that there is an inherent conflict between recommending stratified analysis and then having increased sample sizes, because to do that stratified analysis, which we believe is very helpful, does require additional resources. But we do believe that that investment could be very helpful, because it does provide additional information on programs that can then drive the future design and implementation of solid iodization efforts. So I'll go ahead and end there. And that was actually the final slide, Arnold. I don't know if you want to try to address any other questions, but we are at the bottom of the hour, and maybe it will be time to wrap up. But over to you, Arnold. Thank you.
Yeah, thank you very much. I think, yeah, there are other very important and interesting questions, but I think we have run out of time. We spent 90 minutes. So I want to thank the presenters, Mawuli, Jonathan, and also Roland, for their excellent presentations and contributions. I also want to especially mention new participants in posting all the questions, and I think there's such a richness of views, but also the questions that you listed. I think we have come to the conclusion that we need more interaction and more debates on iodine, which is a field that is constantly evolving, and new techniques and new methods are becoming available to use in this very important endeavor. So we will continue to organize these kind of webinars, but more interactively, and also identify maybe countries that want to present on their case and then have a discussion around it. So with that, I want to close this webinar. We will make the recording available very soon, and also the materials, as well as the questions and the answers to the questions. So with that, I close the webinar, and I thank all the participants very much for the participation. Thank you. Have a good day.